Today we're going to talk about arithmetic series. A series is the expression for the sum of the terms in a sequence. Finite sequences and series have terms that you can count individually from 1 to a whole number n. Infinite sequences and series continue without an n. You indicate an infinite sequence or series with ellipses points, which are the 3 dots at the end. So if we look at the first part, here we have a finite sequence. You just have the list of numbers and it stops. Here over to the right of that, we have a finite series, and you know it's a series because you can see it's the sum, so we have the plus signs in between. Below the finite sequence, we have an infinite sequence because of the 3 dots or points of ellipses at the end. And then over to the right of that is the infinite series of that with the 3 dots at the end. For the first example, it says use the finite sequence that's given here, and we want to write the related series, then evaluate that related series. So the related series of this would be just adding those values together. So 2 plus 11 plus 20 plus 29 plus 38 plus 47. So this would be the series that is related to that sequence. And if we wanted to evaluate it, we would add those all together. So that would be 147. To find the sum of a finite arithmetic series, you can use this formula that we have. So the sum S of n of a finite arithmetic series from the first term to the nth term is S of n is equal to n over 2 times a sub 1, which is your first term, plus a sub n, which is the nth term. So for this, n stands for the number of terms that you have. So that's the formula we're going to use. So if I look at the problem above that, we could have used the formula. So if you have something that's really short, it's easy to just add them up. However, we could have also used the formula. So in this case, we could have said S of, and if you count the number of terms, there's 6. So the sum of the 6 terms is equal to, and our first term you can see is equal to 2. The nth term in this case is equal to 47 because the 6th term is 47. So S sub 6 is equal to 6 over 2, because it's n over 2, times 2 plus 47. And if you evaluate this, it's also equal to 147. This formula is helpful, of course, if you have a large number of terms that you're trying to add together. Of course, if it's something short, it's just a lot easier just to add them. You can use summation symbol, which looks like this right here, sigma, to write a series. So then you can use the limits to indicate how many terms you are adding. Limits are the least and greatest intervals on the values of n for the number of terms. So this lower value right here is the lower limit. And so it's the least value of whatever term you're starting with. So n equals 1, because we start with the first term. The upper limit is the greatest value of n. So if you had 3 terms, so that would be the first term to the third term. That means you would be finding the sum using this summation symbol. And for this inside of the summation, we have the explicit formula for the sequence, and it's always going to be the explicit formula that you are going to be using. You don't use a recursive formula. So if I wanted to find the sum of the first to the third term using the sequence, I would have to plug in those values. So this is equal to 5 times the first term when n is 1 plus 1. And then we would add that. So this would be for n equals 1 to the second term. So 5 times 2 plus 1. So that's for n equals 2. And then plus 5 times 3 plus 1, because that would be n equals 3. So if we add that all together, we end up with 33. Because if you look right here, this is 6 plus 11 plus 16. For this, it says, for example, 2, use the summation notation to write the series 3 plus 6 plus 9 for 33 terms. So that's going to be our upper limit. And then we want to evaluate the series. So in this case, we know that n is going to be equal to a starting value of 1 and all the way up to 33. So 33. So we want 33 terms. Our first term is equal to 3. And For this, we know that if we're doing 3 plus 6 plus 9, we know that our common difference is equal to 3, because if we're using our summation notation, remember we have to find the explicit form. So this is the sum of n equals 1 to the 33rd term. And then again, we need to find the explicit formula for this. So if we know our common difference, then we know the explicit form is a sub n equals your first term, which is 3, plus n minus 1 times your common difference, which is 3. That's our formula. So if we simplify this, we can just distribute that to 3. We have 3n, and this would be 3 and then minus 3, so that would go away. So 3n is our formula for, of course, n values greater than or equal to 1. So this would be 3n right here. So for this, we could plug in 1, 2, 3, 4, 5, all the way up to 33, and then just add it together. Of course, that's going to take you a lot longer than using our formula. So we can use the formula that we have above, s of n equals n over 2 times the first term plus the last term. So you'd have to figure out, well, what is that last term? So that's something that we could do if we wanted to. So we could do s of n is equal to n over 2 times a sub 1 plus a sub n. So if we plugged it in, the sum of the 33 terms is equal to 33 divided by 2 times the first term, which we know is 3. And well, what is the nth term? Well, we have to find. So a sub 33 would be equal to 3 times 33, which of course is equal to 99. So plus 99. And then of course you can do this in your head, or you can plug it into the calculator or do it by hand. So in this case we have 33 divided by 2 times 3 plus 99. And you can see that our sum ends up being 1,683. And of course you can see that's a lot probably faster than having to do this all each term all the way up to 33. Another way we can do this is you can actually use your calculator. So this formula was really more useful before they had what we call the summation notation using our calculator. So if you have a newer calculator, you can do this. If not, I'll show you a different method. So in our calculator, we can go to math, and if you have a newer one, they now actually have the summation symbol, and you can plug that in, and you can see that it looks similar to the way that we write it down. So right here, this first part, you want to put your variable. So you're just going to use this X button right here. So we have the lower limit, which is 1 to 33. And then again, remember that it's always the explicit formula in here. So 3 times X, since we're using X for our variable. And if I hit enter, notice I get the same thing. So that is another way that you can evaluate these. If you have an older calculator, however, you're going to have to do something different, which I'll go ahead and show you right now as well. So if you go to second stat and scroll over to this last column, you notice it says sum. So we could do the sum, oops, second stat and number 5, which is the sum. And then if we do second stat again in the middle column, which is the options, number 5 is the sequence. So we're going to hit 5 again. And sometimes if you have a newer calculator, this will come up. If you don't, I'll show you what will come up in just a second. So the expression is what goes here. So the expression is 3 times x. The variable we're using is x. So the start is 1 and the ending is 33. And we're not going to worry about the step. We're just going to hit enter for paste. So to paste it into this equation, so if you have an even older calculator, you'd have to do this by hand. How do you get those commas right there? The commas right above the 7. So it's always the explicit form, comma, the variables, comma, the starting term, which is 1, to the last term, which is 33. And then you can hit enter. And that would also give you the number of terms. And something else, just to show you, if I take away that sum and just write it like this, and delete that last parenthesis, if I hit enter, notice it actually gives you the terms of the sequence. If I hit my right arrow, I can see more of the terms. So I could also find all the terms that way, which is kind of cool. And if it gave it to me as decimals, you could always hit the math fraction key and write it as a fraction, which is also pretty cool. Okay. So again, we know by using our calculator, this is equal to 1683. And again, to get that, we went to math, and under the math button, just to look again, if you hit math and you scroll all the way down, it's 0, which is the summation right here. And so that was the 0. And then, of course, we also can write it using the other way if you have an older calculator. So it was the sum of the sequence, and then we had 3x, x, 1, 33. So different ways of writing it. And again, to get the sum of the sequence, you had to hit second stat and right arrow over to the last column. So again, I'll do that. So second stat, math is the last column, and number 5, and the middle column is where you get the sequence. So math and number 5, and then you do the same thing and go to the middle column and number 5 as well. So this was the sum, and this is the sequence. The next example, number 3, says use summation notation to write the series 1 plus 2 plus 3, so on, all the way to n equals 6, and find the sum. So this would be easy just to, since you only have 6 terms, write them out. So 1 plus 2 plus 3. I mean, that's not that hard, and you could easily add that up. But we're going to use the summation notation because that is what it's asking for. So for my summation notation, this is the sum of the first term all the way up to the 6th term. To write this, we need to figure out what the explicit form is. So my first term we know is equal to 1. We know that n equals 6. We already figured that out, and d is equal to, so 1 plus 2 plus 3, so our common difference, of course, is 1. So the explicit form, we have a sub n is equal to my first term plus n minus 1 times my common difference, which is 1. So if we distribute and combine our like terms, we get a sub n is equal to n, of course, for n values greater than or equal to 1. So that means this is n. So this is the summation notation. And then it asks to also find the sum. So the sum of this would be equal to 21. Again, it's easy just to add those values up. You could also, of course, use your calculator if you wanted to. So if I go to my calculator again, I could go to math and use that summation notation. So we have x from 1 to 6. And then, of course, x goes here and enter. And again, you get 21 as well. We could also use that formula. So S of 6 is equal to 6 over 2 times 1 plus, and then of course if we have 6 terms and we're only going up by 1, the last term would be 6. That is also equal to 21. But again, it asks us to write the summation notation and find the sum. Example 4 says to find the number of terms in the series, the first and last terms, and then we want to evaluate. So for this, the number of terms in the series, of course, is that upper limit 3. So n is equal to 3. The first term we could find by plugging 1 in for n. So in this case, we have a sub 1 equals 5 times 1 plus 1. So that's 5 plus 1, which is 6. And the last term would be a sub 3 because there's only 3 terms if n is 3. So a sub 3 equals 5 times 3 plus 1, so 15 plus 1. And we can go ahead and add this. So it'd be easy just to do this in your head. So when you add it all up, you get 33. You could also use your calculator if you wanted to, using summation notation, or again, you could use that the sum of the three terms is equal to 3 over 2 times 6 plus 16. Whatever is easiest for you is fine. Doesn't matter which form you use. Example 5, use a calculator to display the first 8 terms of the sequence. U sub n is equal to 7 minus 3n and compute the sum. So let's go ahead to our calculator. So we know that we're finding the 50 terms. So math, go to that summation. And so we have here x from the first term to the 50th term. And so we're going to find the sum first. So we have 7 minus 3x. So the sum of this is equal to negative 3,475. And if we want to write down the first 8 terms of this sequence, we could use, again, our second stat. We're going to go over to options and number 5, which is the sequence. So in this case, my expression here would be 7 minus 3x, variables x. We have, in this case, 50 terms. It doesn't ask us for 50, we only need the first 8, but I'm just going to go ahead and put 50 and paste. And so then you could see your first 8 terms by using your left and right arrow. So for 1, negative 2, negative 5, negative 8, etc. So let's go ahead and write that down. So we said this was equal to negative 3,475. That is the sum of the series. And then again, we did second stat, and we right arrow over to the options, number 5, which is the sequence. And when we did that, we got 4, 1, negative 2, negative 5, negative 8, negative 11, negative 14, and negative 17. Of course, you really didn't need to use your calculator for that. It'd be easy just to plug in n equals 1, 2, 3, 4, 5, 6, 7, 8, but it's just, again, another way of doing the problem. All right, so let's look at the next part. So suppose a sub n is a sequence and n is a positive integer. The sum of the first n terms of the sequence is called the nth partial sum of the sequence. So this is when you're only finding part of the sum, not the infinite sum is basically what we're looking at. That's why they call it a partial sum. So if a sub n is a arithmetic sequence with a common difference of d, then for each positive integer n, the partial sum can be found by using one of these formulas. So we just already talked about the first formula on the other page. So remember, n was equal to the number of terms. A sub 1 is the first term, and a sub n was equal to the nth term. Looking at the next formula, again, it's just another way of doing the problem depending on what kind of information you're given. So if you weren't given the first and the last term and instead you were given the common difference, you might want to use this formula. So again, n equals the number of terms, and d is equal to the common difference. And of course, we know a sub 1 is equal to the first term. And remember, S of n just stands for the partial sum, so that's just the total partial sum. Or we can use our math calculator, which if we go to math and 0, which is the summation, we can use that. And then if you have an older calculator, again, I wrote it out here. And to get that, remember it's second stat, right arrow either to math and number 5, or second stat and, options number 5. So the second step, math number 5, which is the sum, and the second step, options number 5, is the sequence. So for this one, when you're writing it out, we have the sum of the first term to, let's call this the kth term. And so this is the formula a sub n. So a sub n is the explicit form, and k is the number total number of terms, the upper limit. So for the next example, we're going to practice using each of these different ways just to show you that you can use them all, and then we're going to go ahead and write out the partial sum. So it says find the 12th partial sum of the arithmetic sequence. So we know this is arithmetic. So for this one, if I want to go ahead and use the first formula, S of n would be, in this case, equal to n over 2 times a sub 1 plus a sub n. So n is equal to 12 in this case, so S of 12 is equal to 12 over 2 times the first term, which is negative 8, plus, well, we need to figure out what is the nth term in order to find this. So this is one where it might not be faster to use this first formula because we do have to find the explicit form to find the nth term. So for the explicit form, we know a sub 1 is equal to my first term, which is negative 8, plus n minus 1 times the common difference. So what is the difference between each of these terms? And notice that we're adding 5 each time. So we know d is equal to 5. And then of course I would distribute and simplify. So in this case, when we simplify this, we get 5n minus 13. So now I can find the 12th term. So a sub 12 is equal to 5 times 12 minus 13, which ends up being 47. So this would be 47. And then I could use my calculator, do this in my head. So if I go ahead and compute this, I get 234. So that is one way of doing the problem using that first formula. But again, it doesn't always make sense to use that formula because there might be a different formula that's shorter. So if I look at the next one, I'm going to use that second formula. So the second formula, we have S of 12 is equal to n, which we know is 12, a sub 1, which we know is negative 8, plus n, which is 12 times 12 minus 1 over 2 times the common difference, which is 5. So notice that this formula would have been a lot easier to use because I didn't have to do all this work right here where I had to find the explicit form and then find the nth term. So if I plug this into my calculator, just be very careful about how you're plugging in parentheses. A lot of times students get this incorrect just because they don't plug this into the calculator correctly. So I would go ahead and make sure to practice that on your own. So when I do this, I should get 234 as well. So then the last form, of course, is using our calculator. So for the third one, we can find the sum from n equals 1 to 12 because it's the 12th partial sum. We already found the explicit form, which we did over here. So we're going to use that. So 5n minus 13. And then, of course, I could go ahead and plug this into my calculator, and I would also get 234. It doesn't matter which way you use. A lot of the times I just use this way right here because I can plug it into my calculator, and if I forget one of the formulas, it doesn't matter then because then I, again, just use my calculator because I know how to find the explicit form. So here I would pause the video and do example 7 and 8 on your own, and then go ahead and unpause it when you're done and we can check our work. So for example 7, it says find the sum of all the multiples of 3 from 3 to 333. So first we need to figure out how many terms we have. So if they're multiples of 3, take 333 and divide that by 3. That means there are 111 terms. My first term I can see is equal to 3, and my 111th term would be 333 because we're going from 3 to 333, so it actually does give you your last term there. So if I use that first formula, it would be pretty easy. So S of 111 is equal to 111 divided by 2 times 3 plus 333, which gives me 18,648. If I wanted to use the second formula, I could. So in this case, S of 111 is equal to 111 times 3 plus 111 times 111 minus 1 over 2 times the common difference. And of course, if these are multiples of 3, so 3, 6, 9, 12, etc., so 333, then we know we can see that the common difference is 3. So if you plug this in, you would also get 18,648. And the third way to do this problem would be to find the sum of n equals 1 to 111. And you'd have to figure out what the explicit form is. So the explicit form for this, I have a sub n is equal to 3 plus n minus 1 times 3. So distribute, combine like terms, and you get a sub n is equal to 3n. Of course, for n values greater than or equal to 1. So this would be 3n. And that makes sense because it's multiples of 3, so 3 times whatever term value you're on, which gives you 18,648 if you want to plug that into your calculator. And for this last example 8, if the starting salary for a job is $20,000 and you get a $2,000 raise at the beginning of each year, how much will you earn during the first 10 years? So you want the total amount that you're earning all together. So keep that in mind. You're not just looking for what is the year 10, how much are you making? You're looking for how much have you earned total. So in this case, we know our first term is equal to 20,000. Our common difference is 2,000. Our explicit form, we have 20,000 plus n minus 1 times 2,000. And so for this, we simplify, and when we do, we get a sub n is equal to 2,000 n plus 18,000. And so if I find the sum of year 1 to 10, I have 2,000 n plus 18,000 would be the summation notation way of writing it. Of course, I could use any of the other formulas too, and that gives me $290,000. Now you're saying, okay, well, this is, of course, linear, and if I know this is linear, some of you might have written the equation like this: a sub n is equal to 2,000 n plus 20,000. But be careful, because if you're using this formula right here, if I plug in 1, notice that 2,000 times 1 plus 20,000, a sub 1 would be equal to 2,000 or 22,000. So that is not the starting value. So if I use this formula here, which is fine, then you're actually starting with an n value equal to 0. So if I plug in 0, 2,000 times 0 plus this would give me my first term. So just be careful, because I've seen students do that in the past, which is fine. If you do that, though, your sum would be from n equals 0 to 9, because we're starting with a 0 term instead of a first term, which is fine. And then you would use this formula here. So 2,000 n plus 20,000. And that would also give you this value here. And that is it for arithmetic series.